In this experiment, you will be exploring some of the 555 timer application, such as the pulse generation. 555 timer can have two modes. One is the stable mode and the other one is the monostable mode. In the monostable mode, you just create a pulse using a trigger function. The pulse is generated only once and it can be used to trigger some external component. Now the duration of the pulse can be determined by the values of an RC circuit, and these are the external components that we use. And the pulse duration is calculated using this formula. Now as regards to the operation, you can refer to the lecture videos and lecture notes. We also want to create an pulse generator that is periodic instead of a single pulse. That's the astable mode. And you got basically a configuration where the terminals 2 and 6 are tied together, so the circuit can retrigger itself and it keeps continuing generating the pulses. The capacitor basically charges and discharges, and that creates the pulse. When the capacitor is charging, it charges through resistors RA and RB, but when it discharges, it only discharges through RB because the pin 7 is the discharge terminal. Now the times of charging and discharging can be seen from these formulas. When you add them together, it gives you a total pulse period of 0.69 RA plus 2 RB plus times C. And then you got this formula for the duty cycle. Now with this formula, you will easily see you're just gonna get something greater than the 50% at all times. So you cannot go lower than 50% for sure. In this open-ended design team lab, there are various tasks that needs to be done. So make sure to have a fair distribution among team members. So the first team member might do the first design, which is with the 75% duty cycle. And also the same person might be doing the multi-sim and the analog discovery part of the same. The second team member can design the circuit for the 66% duty cycle for these given specifications and verify it using multi-sim, and finally perform the analog discovery experiment of the same. And the last team member might address the questions 7 and 8. So these would require some thinking, and also the last person might be the one organizing the whole team report. Now, as far as the experiment goes, there are Prelab sections. The first design is with the given frequency of 720 Hz and a 75% duty cycle. You should be able to figure the required components RA, RB, and RC. And then just you know that there are multiple solutions based on the capacitor value you pick, and you try to of course pick values available in your component box. Once you have the design completed, then you verify it using multi-sim and use the virtual component of the 555 timer, and make sure to use a load resistor at the output, otherwise it might not work. And as always, you get the screen capture of the schematics, the waveforms, and also you need to have this hand calculation shown clearly. It needs to be typed. So what you're looking from the multisim output is to verify that you're actually achieving the 75% duty cycle and the frequency matches. And then the second part is designing based on this given specifications. The capacitor value is actually specified. Now you're designing it for 481 Hz and 66% duty cycle. And then the multi-sim simulation. The procedure section is about implementing these two designs, but you don't need to place that load resistor on the output. Now you also explain the capacitor waveform, and you record that, of course, along with the output waveform. And that, referring to that capacitor waveform, you explain how this one achieves the working principle of the circuit. And then finally, you make some changes such that you exactly get the 50% duty cycle or something very close, because it's not gonna be 50% with this one. So you need to use some sort of diode or diodes, and you may refer to some textbook or do some literature search or web research, and you're keeping the same frequency though. And finally, you may, once you get 50% square wave pulse, you will convert this into a triangular wave. So you'll use this circuit, but you use some additional circuitry that you convert this into a triangular wave, something like this one. So try to make it look like this as much as you can. And also, please state the contribution of each team member, and at the end, please specify what were your gains working as a team